Morning, ladies and gentlemen. So today we are looking at more lessons, more information about square roots. Now, we've been talking very much about if it's a perfect square root, then it's a rational number and looking at that idea of rational versus irrational. Today, we're going to be looking at the solutions to square roots. So really focusing a lot on the perfect squares. Now, I want to be able to really focus on how can the relationship between perfect squares and square roots, or how can I use, the relationship to calculate solutions. So I know that 2 times 2 is 2 squared, and negative 2 times negative 2 is the quantity negative 2 squared. Now, something to notice, if the negative is not inside parentheses with the number, then we typically don't multiply negative 2 by negative 2. Okay, and I can give you an example of that in a second. Okay, these both have a value of 4, because 2 times 2 is 4, and negative 2 times negative 2 is positive 4. So the value of the square root of 4 could be 2 or negative 2. Here's an example. The square root of 25. So please write that in your notebook. It could mean the square root of 5 times 5, or it could mean the square root of negative 5 times negative 5. Okay, we don't know because they both, the product of each of those is 25. So the solution could be 5 or it could be negative 5. Okay, this is the why of what we're doing. Now, just as a side note, if I wrote negative 2 squared, we're going to assume, and assuming is bad, that that's negative 2 times 2, and that would be negative 4. If I write negative 2 squared, we're going to assume negative 2. This one's a little more precise, and that's a positive 4. If I give the problem, if I have any way of helping you with the problem, I would definitely point this out, but just kind of as something to note about integers and exponents. Okay. Now, in real world usage, distance, measurements, equations, we often assume, there's that word again, the use of positive value. When you get into high school, when you start working with quadratics, you are going to get to the point where you have to solve the equation based on if it was a positive or if it was a negative. But for our purposes, we're just going to assume positive. Okay, just to give you that clarity. Okay. Notice that the square root of 2 times the square root of 2 equals 2. Because the square root of x and x squared are inverse operations. Okay. Now, what if there's a fraction? Oh my goodness. Okay. So what if I said I need you to find the square root of 64 81sts? Okay. Well, that's the same as the square root of 64 over the square root of 81. Oh, thank goodness, these are perfect. Okay, so this is going to be equal to 8/9 or -8/9. If in homework they're just asking you the solution, they probably want you to say the positive or the negative. But the minute we start getting into using them, including in equations, just give the positive. Okay. So here's an example of an equation, and this is going to feel very simple after other things we've done. But let's say I have the equation x squared equals 81. Well, what's the value of x? We prove it by finding the square root of both things. The square root of x squared is x. The square root of 81, oh, thank goodness, it's perfect. So it's 9. And that is how you would solve that really one-step equation. Okay. Let's look at a couple more examples. Okay, and I'm literally pulling the example up right now. Okay. What if we had one that said y squared equals 36/49? Well, the square root of y squared is going to be y. We need to isolate y. The square root of 36/49. Oh my goodness. Okay, I'm going to tilt this just a bit. There we go. So y equals the square root of 36 over the square root of 49. Y equals 6/7. Okay, I know that this is 6 because 6 times 6 makes 36. I know that this is 7 because 7 times 7 makes 49. So these are perfect squares, and that's pretty much all we're going to be dealing with. Okay. All right, hopefully that makes plenty of sense. It's just a way of using the square roots that we already have been studying. And I can't wait to see you in class.